Hello everyone, good afternoon. Dear authors and invited guests, welcome to Technical Session 10B. Myself Richa Shah and this session will be moderated by me. On behalf of the Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 9th International Conference on Smart Trends in Computing and Communications held in Pune, India. The 9th edition of this conference is being organized in a hybrid mode. The physical event was held yesterday in Pune, and the virtual event is being held through Zoom on the 30th and 31st January. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations each, and each presenter will be given 8 minutes for the presentation and 2 minutes for question and answers. On 7 minutes, I will raise a gentle reminder. In this session, we will have there is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, you can write it to me in the chat box. So before we start, I'd like to introduce you all to our session chair, Dr. Nidhi Tiwari ma'am. Ma'am is an associate professor and R&D head in electronics and communication engineering at Sage University, Indore. With 13 years of experience in her field, her expertise spans with VLSI design, intrusion detection and prevention, computer networks, network security, cybersecurity, AI, ML, and data science. Dr. Tiwari is dedicated to advancing research and education in their cutting edge fields. Welcome to the session, ma'am.
Thank
Moving
you.
on next. Moving on next, I'd like to call Mr. Ravin Kumar for his paper titled Adaptive Based Representation Theorem, an Alternative to Binary Number System. Sir, please can you start with your presentation?
Sure. Can I share the screen in this? Hello.
Yes, sir.
Okay. Okay. Please let me know when it is visible.
It is visible, you can start.
Okay. Yeah. So hi everyone. Myself Ravan Kumar, and I'm here presenting my work, Adaptive Based Representation Theorem, an alternative to binary number system. So as we know about binary number system, it's basically a number system where data is represented in the form of 0 and 1 with a base value equal to 2. That is 2 to the power 0, 2 to the power 1 that became the base value. And it is heavily used in everything that is digital these days, including like microprocessors, memory devices, communication systems, and basically everything, including data representation, transmission, as well as storage mechanisms, including compression, error correction. Everything relies on this number system in digital devices. So the mathematical representation of this number system is like this. So if let's say we have n number of bits representable with you can say b0, b1, b2, and the total numbers which can be represented in such bit is let's say set bn. So this is basically the mathematical representation of the binary number system. So now what is the problem statement? The problem statement is can we have a number system which can work as an alternative to binary number system, but with two things in mind. One is, can it have a same storage capacity as binary number system, and is all compatible with all the existing data storage, data compression, and data error correction and mechanisms. Okay, so with that in mind, the objective of the paper was proposing a number system and then having a theorem with the mathematical proof to say that it can be used as an alternative to binary number system. So this is the proposed number system basically for n number of bits, that is d0, d1, d2 till dn minus 1. We can calculate the base value, which is like, for example, let's say this was hypothetically binary number system. So this would have been 2 to the power 0, this would have been 2 to the power 1, 2 to the power 2. So what we are basically doing is we are here calculating the base value for our proposed number system first. So this is a mathematical representation of how we will calculate the base values. in both the cases where the total number of bits is greater than equal to greater than 1, and in the case of otherwise, this particular format will be followed for this. Now, v is a decimal number. So to represent v in our proposed number system, this particular mathematical expression is followed, where minus 1 to the power epsilon I into di, where what is di here? Di is like this, you can say the data, basically, that is in the form of 0 and 1 only, into the base value, which we are calculating from here. So when these all get multiplied and summed up, we get the number which is in the decimal number from our proposed number system. So where here again, let's say di is 0 and 1, that is 0, 1 only, and epsilon is basically a function which is here to adjust the overshooting and undershooting of the number. So basically in the previous number systems, people have attempted the same thing, but they were falling in two things. Either the numbers were having over representation of particular number and missing other numbers. So to adjust this, we added these particular values. Okay, and this is our theorem, which is like formally in mathematical terms. Let's dn, that is let there a set b which is not the set of number representable using n number of bits in binary number system, and set a which is not the set of number representable using n bits in our proposed adaptive based representation number system. Then both of these sets are equal. That is, let's say if there are suppose 4 bits, so whatever numbers that binary can be represented in 4 bits, all those same numbers will be representable in our adaptive based representation number system, or ABR number system in short. This that's our theorem, and this is a mathematical proof of the theorem. Okay, and here we have used the approach of inductive hypothesis. So basically, binary number system set B is representable with this form, this particular way, which is like whatever the value of bits time 2 to the power I, where I is basically the index of the bit. That's how we calculate the set B here. Set A is calculated using this formula, where minus 1 to the power epsilon I di into b to the di, where b is the base, di is the bit value, and epsilon is there to prevent undershooting and overshooting. So we have taken 3 cases. For case 1, as we know, binary can represent only 2 numbers, like there is 0 and 1. Here we have shown that in ABR also it represents 0 and 1, that is b is equal to 1. Similarly, for n equal to 2, that is when the total number of bits we have equal to 2. Then we checked for binary number system, it can represent 0, 1, 2, and 3, very obvious. Then for adaptive based representation, we took help of these conditions, basically these one, to calculate bit value, base value, basically. Yeah. So this became minus 1 to the power epsilon 0, and then d0 b0, and minus 1 to the power epsilon 1 b1 b1. So this d0 and z1 d1, it can have any value, from 0 1. It can be 0, d0 equal to 0, d1 equal to 1, or any possible permutation combination. So then for all such values, we calculated these values, and it comes as like 0, 2, 3, 1, that is 0, 1, 2, 3, again the same set. So it means both the sets are same. Now, basically the mathematical proof is something like this. So the basis in binary number system is mathematically represented with this. So the basically the interesting, you can say the term is this particular one, bns underscore base. It what it means is when all the bit values is 1, that is 1 1 1 1 1, then binary represent the maximum number. So that is why we are subtracting this particular term from these. But in our case, uh, what actually happens is, uh, just remember these terms for some time. I'll explain later. In ABR number system, the decimal number system is represented using this particular term. So, and one very obvious thing to remember here is, see, if this epsilon, this particular term is 0, that is epsilon I is 0, then this will become 1. And when this epsilon I is 1, this thing will become negative. That is, you can say, that is, if I is odd, then it will represent the maximum, you can say, number, because the value of ei will become 0. So similarly here what we have showcased is when I is an odd number, this particular term will become 0 and it will represent the maximum number. So instead of subtracting this term, which is in the binary number system, what we will be subtract is all the bases where j is an odd number from here and is less than I and less than the current value of the index, basically. And a generalized form of B, that is base calculation, then is I plus 2, where if I is 0, 1, and a number of bits to be represented is greater than 1. Otherwise, this particular term. So this term, I've discussed how we derived this. Similarly, this is the inductive hypothesis for all the cases where n is greater than or equal to 2. We have assumed for k, both the sets are equal. Now, can we show for k plus 1 these both values? That is the number which are represented in binary and the number which are represented in ABR. Can they both be same? So for this again, what we basically have to show is the bk is can we have bk equal to 2 to the power k plus 1 minus 1 minus summation of bj where j is odd. And if you remember here itself we have proved this particular term because when I is odd number it is representing the maximum value. So hence proved like b k plus 1 equal to a of k plus 1, and with the inductive hypothesis we can say both the sets are equal. Now this is basically a tabular representation of all the values or all the base values of binary number system and our proposed number system. One obvious thing which we can see here is because binary goes with base values of 2 to the power 0, 1, 2 to the power 1, 2, like binary, and our ABR number system is 2, 3, 4, 12. One obvious thing is when these numbers are having index which is you can say even, that is 2, 4, 6, 8, the base values of ABR and binary number system, they both are same. This is one of observations which we found. We have also mentioned it in our paper. And one sample representation of data. So what we took was we took 4 bits. We represented all the possible numbers in binary and ABR. That is from 0 to 15. This is binary representation and this is ABR representation.
Excuse me, sir. Sorry to disturb you, but around 7 minutes are over. Can you please wrap up?
Yeah, sure. Okay, it's almost done. Yeah. So this is binary representation. This is ABR representation. We can see all the numbers have unique representation. Example, you will not have any 0011 which represent any other number apart from 1 in ABR. Now, regarding the application, it can be used in data storage and data transmission as proved from theorem. Both the sets represent same number of decimal. Steganography and you can say data error detection and correction mechanism and data communication. One example is of a steganography. Let's take 8 bits of binary data. Last 4 bits, this represent 9 in binary. What we did was we represent the equivalent of 9 in ABR number system, which is 1111, which you can also see from here 1111, and we concatenated it, and it became this number. So the idea is, in steganography means hiding information in plain sight. So if you don't know which bit represent ABR and which bits are from binary number system, it is very difficult to read this number. So that's how it can be implemented in steganography. Now regarding Hamming code, what we have done is we took the number 13 and Hamming code basically error detection and correction mechanism. We took the number 13 in binary and ABR. We calculated their corresponding parity bits in case of even parity. And with parity bits and data, it became 11001110 binary number system, and in ABR that is 1010101. And in transmission, then we have assumed this particular one became 0. That is with some transmission error. So this is a error bit now. Now we want to see can the existing Hamming code detect which index value, that is index is 7 for this bit, can we detect which one was having the wrong data during transmission. So then we again calculated the syndrome bit of S1, S2, S3. In both the cases, it came as 111, which is 7. That is the leftmost bit have to be flipped, and then we got the correct value, which was which was in ABR and BMS, both the cases. So thus it is now compatible with existing Hamming code as well. Now regarding data compression compatibility, there are two kinds of data compression algorithms. One is base dependent. So if it is base dependent, in our algorithm we have showcased all the data which is representable in n bits in binary is also representable in ABI number system. So it is compatible with all the existing base dependent data compression algorithm. And if the data compression algorithm is base independent, which means like only 0 and 1 is needed and no base value is needed, such as Hoffman coding, then in those cases also it is compatible as there is no requirement of base value itself. And these are the few references which we have used. So basically the conclusion is ABI number system with mathematical proof can be used as an alternative to binary number system. And it is compatible with all the existing data transmission, compression, and error detection and correction mechanisms. Thank you.
Any questions from the session chat?
Yes, Ravin, so hello, am I
Yes,
audible?
yes, you are audible.
Yeah, so what kind of software you have used for this?
Sorry, can you repeat actually?
So I think you have done any simulation, right?
I have, yeah, it's basically Python program I have written to check the
Oh,
compatibility
yes, yes.
and mathematical proof.
Python program.
Yeah.
Yes. So on which platform you have done?
You mean operating system?
Yes.
It's Ubuntu basically. It's Python program on Ubuntu just to cross check these base values.
Uh-huh.
This tabular format. One second. Yeah.
Yeah.
Basically,
Yeah.
these base values I cross checked, so there is no
Mm-hmm.
space for any error, and then I cross checked is the representation of this bit unique in ABR and binary. So binary, to we all know because everyone is using it. For ABR, I have cross checked, and important thing was
Okay.
the mathematics. So the proof is also there.
Right. So have you mentioned algorithm over there?
No, it's this particular. So basically, this particular expression, right? If my screen is visible. So this expression can be itself written in Python, where this sigma becomes a loop. It's basically a for loop where j equal to 0 to j less than k, and then we can basically simply calculate with a simple for loop these values of base. It's very
Yes,
small
you are.
program.
Yes, you are right. I'm supposing to write some algorithm. So have you mentioned or not? I'm just asking about algorithm. Am I audible?
Yeah, yeah, you are audible.
Yeah, yeah. I'm just asking about algorithms. So have you mentioned here or not?
Yeah, yeah. In the paper, I have mentioned in
Okay.
application
Okay.
applicability where it is
Hmm.
compatible. For example, Hamming code is an algorithm of data detection and correction, and I've showcased example also where the compatibility of our ABI number system is there alongside with binary. And for the data compression, I've showcased example of Hamming code. So Hamming coding is also a data compression algorithm basically. So that also I have showcased for the applicability point of view for this number system.
Okay. Okay. Thank you.
Okay. Yeah. Thank you.
Okay, thank you, sir, for your presentation. Moving on next, I'd like to call Arya Pendarkar for her paper titled AI Applied to Stock Market Prediction. Ma'am, can you start with your presentation?
Yes, just a minute. I'll be sharing my screen.
Yeah.
Is it visible? Hello.
Yeah, it's visible.
Okay, so good afternoon, everyone. My name is Arya Pindharkar, and I'm here to present our survey paper titled AI Applied to Stock Market Prediction, co-authored with Tanmay Pampatwar, Mrunal Zombade, and Ashwini Bankar. This work was conducted at SCTR's Pune Institute of Computer Technology, Pune, and is part of the SMARTCOM 2025 conference. In this presentation, I'll discuss how AI is revolutionizing stock market forecasting, combining machine learning, deep learning, and sentiment analysis to address challenges faced by traditional methods. So, stock market prediction plays a critical role in financial decision making. Traditional methods like ARIMA and moving averages often fail to capture non-linear trends and complex patterns in stock data. So this is where artificial intelligence comes in. Machine learning and deep learning models can process vast amounts of data and identify hidden patterns, significantly improving forecasting accuracy. The aim of our survey is to review these AI-driven techniques, explore their methodologies, and highlight their strengths and limitations. So AI-based stock prediction relies on a range of machine learning and deep learning models. For instance, logistic regression is effective for binary predictions, such as whether a stock's price will rise or fall. Random forest uses an ensemble of decision trees to improve accuracy and reduce overfitting. Whereas XGBoost is a gradient boosting algorithm and it handles large datasets efficiently. And deep learning models like LSTMs and RNNs are particularly powerful in analyzing sequential data, making them ideal for stock market prediction. In some cases, hybrid models combining LSTMs with XGBoost often offer even better results for leveraging the strengths of both approaches. So let's look at how these models are applied in practice. Our survey analyzed various machine learning models, including logistic regression, random forest, XGBoost, and support vector classifiers. Each model was evaluated based on its ability to handle stock market complexities, such as nonlinear patterns and high dimensional data. Deep learning models, especially LSTMs, excel in capturing time series data. Meanwhile, hybrid approaches like combining sentiment analysis with technical indicators offer a more comprehensive view of stock market movements. Sentiment analysis plays a vital role in stock market prediction by integrating market psychology. For example, data from social media platforms like X, now former Twitter, and financial news articles is processed to determine sentiment, whether it's positive, neutral, or negative. This sentiment is then combined with technical indicators such as moving averages and the relative strength index to refine predictions. By incorporating sentiment, AI models provide a broader perspective, capturing the emotional drivers behind market trends. The quality of datasets is crucial for building effective AI models. Our survey analyzed datasets that included historical stock prices, technical indicators like RSI and MACD, and sentiment data from sources like Yahoo Finance and Twitter. We evaluated model performance using metrics such as accuracy, precision, recall, and FN score. Backtesting was also performed to assess the reliability of predictions under real-world conditions. To provide a comprehensive understanding, our survey reviewed various research papers. For example, the first finding was study shows that artificial neural networks, which is ANNs, outperform traditional models like ARIMA in volatile markets. Second one was deep learning models like LSTMs excel in time series data analysis, capturing sequential trends. Third one was hybrid models combining LSTM with XGBoost outperform standalone approaches, achieving greater accuracy. Sentiment analysis emerged as a critical component, enhancing both machine learning and deep learning models by integrating market sentiment with technical data. This block diagram illustrates the workflow we analyzed for integrating forecasting with sentiment analysis. Stock data sourced from Yahoo Finance is combined with financial news sentiment data. The data undergoes pre-processing and sentiment analysis is performed to classify news as positive, neutral, or negative. The final data set is split into training and testing sets. Machine learning models such as logistic regression or XGBoost are trained and tested for predictive performance. Results are evaluated using metrics like accuracy, and the models are refined as needed for robustness. Now, let's look at the results. Our survey showed that logistic regression achieved the highest accuracy at 83%, followed by support vector classifier at 75%. Both models are effective for binary classification tasks. Random forest and XGBoost demonstrated moderate accuracy at around 65 to 68%, while K-neighbors classifier and decision tree classifier had lower accuracies, around 55%. These findings highlight the importance of choosing the right model for financial forecasting. Keep in mind that these values of accuracies were based on our implementation. So we had considered various parameters which were different from the ones in the research papers. In conclusion, AI techniques, particularly logistic regression and SVC, are highly effective for stock market prediction. Ensemble models like Random Forest and XGBoost provide promising avenues for further refinement. This survey underscores AI's potential to revolutionize financial forecasting, offering valuable insights for future research. Thank you for your time and attention. If you have any questions or would like to discuss this further, feel free to reach out to me at the email provided in the slide. I look forward to your feedback. Thank you.
Any questions in the session, sir?
No.
Thank you so much.
Thank you for your presentation. Moving on next, I'd like to call Mr. Ankit Patne for his paper titled Cloud-Enabled Learning Management Systems, a study on scalability and personalization. So can you please start with the presentation?
Yes, sure. Am I audible clearly?
Yeah, you're audible.
Okay, I'll just share my screen. Okay, I hope my screen is visible.
Yes, sir. We can start.
Okay. Hello everyone, I'm Ankit Patne. I'm really excited to share our work on cloud-enabled learning management system. LMS platforms today face two critical challenges: scaling for millions of users and delivering personalized learning. Our research bridges this gap with a cloud-native architecture leveraging AWS services. By combining serverless computing, microservices, and real-time analytics, we have built a system that scales dynamically while tailoring content to individual learners. Today, I'll walk you through our architecture, user workflows, and results demonstrating 60% faster responses times as compared to monolithic systems. We have built system leveraging AWS cloud services to dynamically scale our resources. So let's begin by understanding the system architecture that powers our solution. Our LMS is built using microservices architecture to ensure modularity and independent scaling of services. Here's how the core infrastructure works. AWS S3. It is used for storing course materials and media files. We use AWS Lambda, which is a serverless compute function for automation. We have used load balancers to distribute traffic efficiently among all the users. We are using AWS Athena to enable real-time analytics and ranking calculations. We are using EC2 instances, which handle user authentication and our backend services, and is also used for cloud hosting the platform. And most importantly, we will be using AWS Elastic Disaster Recovery, which ensures high availability and fault tolerance. This helps us build a resilient architecture, and it ensures our LMS can efficiently serve thousands of concurrent users without compromising performances. So this architecture gives us that brief overview of how the platform works and revolves around cloud. Next comes user flow. Our system is designed to serve three primary user roles for the application. First is super admins, who manage the platform-wide settings. Admins can upload courses, monitor assessments, and manage students' activity. Students can access learning materials, take assessments, and receive performance feedbacks. User authenticate via JWT authentication based handled by AWS Cognito and EC2 backend servers. Course content is securely stored in AWS S3, while assessments and feedback are managed by PostgreSQL on AWS RDS service. AWS Athena is really helpful in processing real-time analytics to generate rankings and performance insights. This structured workflow ensures an efficient, personalized, and data-driven learning experience for the students. Okay. Next comes KPIs or key performance indicators. To measure the efficiency of our system, we focus on key performance indicators such as serverless processing, which reduces the infrastructure cost by automating tasks with Lambda. We are using S3 and Athena to enable fast content retrieval and providing real-time and accurate analytics. The microservices architecture ensures independent scaling of different components. These KPIs highlight how our system optimizes cost while delivering high-speed and reliable services. Next comes one of the most important aspects, reliable and scalable computing. Reliability and scalability are critical in LMS handling thousands of concurrent users. So we are using AWS Elastic Disaster Recovery Service to ensure nearly zero downtime by replicating data across multiple regions. Serverless architecture dynamically scales resources based on demand, reducing costs, and also improving efficiency. This means that even during peak exam seasons, our system remains stable without performance degradation and can handle large amount of users with minimal cost. Next comes video on demand, AWS architecture. This is one of the most innovative aspects of our LMS is the video on demand streaming architecture, which is built on AWS. This enables students to access high quality adaptive bitrate streaming for a seamless learning experience. So here's how it works. The source videos are uploaded to S3 bucket, which in turn triggers the Lambda functions. The Lambda function triggers AWS Media Convert to transcode video into HLS format. HLS stands for HTTP live streaming format and provide adaptive bitrate streaming to users with depending upon the internet speeds. Lambda function automate the encoding process triggered by EventBridge AWS service. Amazon CloudWatch monitors encoding jobs and ensures the system health, and also help us monitor the system working efficiently and effectively. The processed videos are then stored in destination S3 buckets in a different file format, which is suitable for streaming. To be more specific, transport stream or .ts format, MPEGTS. Amazon CloudFront then distributes the video globally, reducing the latency and ensuring smooth playback. This happens with the help of CDNs or content delivery networks. Then, at the end, notifications via Amazon SNS or simple notification service informs admins about completed processing jobs. Hence, this architecture guarantees that videos are delivered in the best quality possible, adapting to students' internet speed without buffering issues and latency. To be more precise, HLS ABR with produce 5 types in 1920 x via 1080p format, 1280 into 720p, and 640 into 360p, 480 into 270p, and 960 into 540p. These resolutions will vary depending upon the internet speed of the user dynamically. Next comes database hosting and monitoring. Efficient database management is crucial for scalable learning management systems. Our LMS uses PostgreSQL on AWS RDS, ensuring high availability, security, and automated backups. Amazon CloudWatch provides real-time monitoring, automatically detecting slow queries and high CPU usage times and potential failures. This ensures that database operations remain smooth, secure, and efficient under all workloads. We can witness all the metrics on the dashboard provided by AWS to handle the workload efficiently and see if the database is working effectively without any issues. These visual representations to help the users to conveniently use the learning management system platform. To conclude, our study demonstrates that a cloud-enabled LMS is significantly more scalable, reliable, and cost-effective than traditional on-premises solutions. It provides almost 60% faster content delivery versus the monolithic systems. We can support thousands of multiple users supported with less than 1 second of API responses with the help of load balancers by distributing load. Then 30% cost reduction using the serverless auto-scaling. And we provide almost 99.99% uptime, ensuring continuous learning without any interruptions. And lastly, if we achieved nearly 50% faster data retrieval using AWS Athena for the real-time analytics. Thank you for your time. I'm happy to take any questions now.
Ankit,
Yes.
can you please show me your runtime data?
This.
Again,
What?
yes.
Yes, this is a visual representation of our AWS dashboard, which we have hosted database. We are using PostgreSQL, and it has been hosted on AWS
Sorry,
RDS.
which scale? Can you please repeat it again?
We are using PostgreSQL, which is
Okay.
hosted on AWS RDS. RDS stands for
Right, right.
Relational Database Service.
Yes, right.
And most importantly, it is in an isolated environment, VPC security group. VPC is Virtual Private Cloud. So it's
Yes.
run an isolated environment, ensuring data security
Mhm.
without any interruptions or like DDoS attacks, like any cyber issues. So that ensures safety. And we
So
can
have you
always monitor
checked
this.
against DDoS attack?
No, we haven't checked that yet, but we have monitored the dashboard using concurrent users with our like college staff and students. We have tested the platform to run multiple queries, like almost hundreds of users were accessing the platform, streaming the video files. Video files are basically the video lectures that are being uploaded by the users, and we monitored the live status and of the database, how it handled queries, and also ensure that there was no lowest latency possible for the streaming of video files. And
So what was the duration for this stream?
duration for videos?
Yeah,
Yeah,
for analysis.
we have uploaded multiple videos actually, and
Yes.
also in multiple formats. Some were almost 30 minutes
Yeah,
long.
sure. But what was the duration, like 1 hour, 2 hour?
Yeah, 30 minutes.
Yes,
30 minutes is
okay.
the highest video streaming that we have done
30
because
minutes.
it
Okay.
costs us,
Yeah.
and some services are expensive. So, and the charges are based on per second of the video file being converted and being streamed to and multiplied by number of users who are streaming the file. So that costs us. So that's why we are not yet uploading larger files like 1 hour, 2 hours in the initial phases because we are still in testing phase. And
Okay.
that's with the help of support provided by our guides.
Right. So you can also try for DDoS attack.
We haven't yet specifically tried, but I'm aware of the
You
ideas of
can.
that.
You can in future. Yeah.
Yes.
Yeah. Okay.
Yes, but we are aware of that cyber threat at distributed denial of service, where
Right.
it is caused by large number of users trying to send like unwanted requests to our platform, and we need to handle that situation. So that's and so with the help of CloudWatch and monitoring all the database queries and how our application is performed, like the video streaming architecture. One of the most important aspect of this video streaming architecture is using AWS CloudFront to provide videos through CDNs, content delivery networks. So what it basically does is it streams the video to the users with the help of edge connected servers, and the video is streamed through the nearest location of which the user is accessing. Like if a user is in Mumbai, so the Mumbai region of AWS will serve that user. And if user is somewhere located globally in another region, so the nearest edge connected server will provide this video streaming to the user based on the location. This really ensures that the video is lower latency, and also that lot of load is not coming on a single server, and it is distributed across multiple servers. And also, while accessing the platform, we are using load balancers to ensure that multiple users can access this platform even if they are not only watching videos, they are accessing some files or just course materials.
Okay, thank you.
Yeah, I hope I was able to answer your query.
Yes, sure.
Yeah, thank you. That was a good question, and we'll surely check for DDoS attacks.
Yes,
Yeah.
for DDoS. Yes. Okay.
Thank you for your feedback.
Thank you for your presentation, sir.
Thank you.
Moving on next. I'd like to call R. Mehala ma'am for her paper titled Content Preserve for 3D Video Stabilization Using Wrapping Techniques. Ma'am, can you please start with your presentation? I'd like to call Mr. Bijit Narayan for his paper titled Digital Forecasting as a Tool, Assessing the Performance of Public Sector Banks in India. So please can you start with your presentation?
Sure, ma'am. Hello, am I audible?
Yeah,
Okay, so I'm sharing the screen.
okay.
Hello.
Yeah, so we can see your screen. You can start.
So first of all, thank you for giving me this opportunity to present on my research. So my name is Bijit Narayanan. I'm a final year. I'm a MBA student from Amrita Vishwavidyapeetham, Amravati campus. So my topic on the research is digital forecasting as a tool assessing the performance of public sector banks in India. So this research was done in the guidance under the guidance of Dr. K. Sarvani, and my colleagues are Dinesh and Ayush Rai. So first of all, I'm going to my research presentation. So first, then these are the contents on my research, which include abstract, introduction, literature review, and questions on research, methodology, findings, and banking specific observation, and finally on discussion conclusion. So firstly, coming on abstract. So this study is about the assesses how digital finance tools which affects the bank performance in India, and it focuses on two key economic factors like GDP and inflation. And here, non-performing NPAs, which is known as non-performing assets, which negatively linked to GDP growth and inflation. And forecasting shows forecasting with the help of Sarima model, which shows NPAs are increasing. So which gives the more opportunity to improvement with fintech solutions. So these are the objectives of this study and research. So coming to introduction part. So digital finance, it enhances efficiency in tracking and managing NPA, which aids banking solvency, and it boosts more profitability. So as digital and everything coming to introduced, so this can helps to manage NPA. And coming to this second point, NPA arise when loan aren't paid within 90 days, which it can also affect many stakeholders like customers, bank, and even government officials, and even our economy. And e-banking, it also provides alerts, and which helps in capital formation, including bank finances. So e-banking also it helps to reducing managing NPAs, and it can make more profitability and more solvency. So coming to literature review. So digital transformation has helped to identify the error and identify and reduce NPAs. So it can be make easier for managing NPAs, and it is a completely microeconomic variables, like which includes GDP and inflation. So NPA is also related on GDP and inflation, which heavily influence bank performance. And it advantage technologies like AI and IoT and blockchain. This have also improved many banking efficiencies. And in innovation fintech like P2P lending, robo advice, and blockchain are also transforming financial systems. So innovation in fintech also, this is also the review help for the digital banking. And coming to research questions. So by doing research, so these questions has been arise like, firstly, what is the link, means relationship between the economic factors like NPS in many public sector banks, and how next in is how do GDP and inflation impacts. So how GDP and inflation impacts on NPS in public sectors, and can past NPF data which can predict future trends, so that we can banking sectors can make future decision for their improvement based on the past NPA data. And how do fintech apps, many mobile fintech apps help bank adapt to GDP and inflation changes in future. So coming to the methodology, so this studies examines that this study acknowledges 12 public sector banks over a decade. So as this research was done in 2023, it is regarding 10 years from 2013 to 2023. And this data we have collected using Provis IQ database and many secondary sources, like we have many internet access and everything we have done. And analysis, it includes correlation and a regression to assess NPS relationship with GDP and inflation. So we have done this analyzing using correlation and regression, which can analyze NPS in the public sector banks over these last 10 years, that is 2013 to 23. Now going to findings. So here are the findings of this NPA and a digital financing. Like first one is correlation analysis. So by these findings, we can understand that NPS, which is negatively correlated with GDP and inflation. And coming to regression analysis, so inflation has is a robust negative effect, and inflation and GDP also it significantly impact NPA. And coming to forecast, so with by looking on the past NPS, we can help for making requiring strategic reforms for improve the NPA, to manage NPA and making banking more profitability. And here are the bank specific objectives. Like, so these are the banks which has a higher NPA chances sensitivities, and for high in banks like SBI, Bank of India, and the Central Bank, these are the high NPA sensitive. And coming to medium, it includes Punjab National Bank and Indian Bank. And in less sensitivity, it is Punjab and Sindh Bank and UCO Bank. And coming to the final conclusion, so after this research, I'm going to conclude on my research, like digital tools have made NPA management efficient by reducing financial instability, and economic forecasting also shows a positive trend. So even NP have done in the future, means done in past, we can by analyzing the past NPA, we can make decisions and many strategies to improve it. And this is a most critical role in mitigating many risks. And finally, bank needs to focus on loan recovery and leveraging fintech. So by introducing fintech, it is easy for to focus on loan recovery and many better assets management. So thank you for and any you can ask my questions.
Thank you. No questions from my side.
Okay.
Thank you for your presentation, sir.
Thank you, man. Thank you, man.
Mm. Moving on next, I'd like to call Mr. Prashant Butts for his paper titled Optimizing HR Utilization in the BPO Industry, the Power of Predictive Analytics. So please can you start with the presentation? So it's not in the meeting. I'd like to call Rohit Patil sir for his paper titled RAG Chatbots, Implementing LLMs in Retrieval Augmented Generation. Can you please start with your presentation?
Hello, am I audible?
Yes, sir.
Okay. Is the screen visible?
Yes.
Okay. Hello everyone, my name is Rohit. I'm from Rashid Shah College of Engineering, studying in computer science and business systems. So the context of our paper is the businesses which are increasingly relying on the chatbots for automated customer support, but most of the existing systems are very giving generic responses that are lacking in personalization leading to the customer dissatisfaction and inefficiencies in addressing company specific queries. Uh, let's say we have a organization and they have a chatbot that has key value pair chatbot, and the user is asking a query that is very complex in nature, and the chatbot, which is only working on the key value pair basis, won't be able to give the correct answers or the relevant answers. So we need a chatbot, and improvised chatbot that will understand the user's query in different languages in all the different complex structures and give the most relevant answers, so that the organization can not only retain the customers but also satisfy their needs on the online portal itself. So that is our objective. The aim is to develop a chatbot that learns from the company specific data, adapts to the new information that comes its way, and continuously improve the responses to offer personalized customer support. So why is it needed? It's needed to enhance the customer satisfaction, streamline the support processes, and reduce the operational cost. All the operational cost of having the customer support human beings at the back end would be reduced if we have an efficient chatbot that uh, satisfies the customer on in the online mode itself, and also bridging the gap between the chatbots and the uh, generic and the company specific chatbots. This solution ensures that we have a better engagement and adaptability to evolving business needs. Coming to the literature survey, we have a few references. So first was the research uses. First was from Abdul Aziz Wahuya and uh, n- these people, and their their research was based on LangChain and GPT 3.5 Turbo and Pinecone to generate coherent chatbot responses. And the dataset they used was the PDF document. The limitations of this was the data quality dependency. So the data which was fed using only PDF might have da- uh, de- might have inaccuracies which were leading to the uh, inefficient answers. And the second one was from Kaivalya Pandya, the same, but they used the data which was web scraped data. So the limitations of this data was again inaccuracies in the data and scalability challenges. The third one was again a RAG solution only using the LLMs, and they use a external database to retrieve the data. Uh, and fourth one was from Kavita Moholkar, and they, this was not a chatbot, but they used various classification techniques to improve the accuracy. So we have added this research to analyze how to uh, test or how to have a benchmark scores for all the LLMs. And the fifth one was from M. Hendricks, uh, where again they used the LLMs and AI powered chatbots, but their limitations was that there was no explicit source that they were taking from. They were giving these data by themselves, and that was their limitations. So the challenges was existing system was real-time performance. Response speed may be impacted during the peak usage or with limited server resources, and unknown language issues. if the chatbot was not trained on the languages the user speak, then the chatbot might not be able to give the correct answers. So a proposed solution is to use a LLM along with a retrieval system that will learn from the data of the organization and would give the personalized answers to the user's query. So first we have a user interface so that communicates with the user, and then we have the NLP module which processes the user's input to enable a context aware response. So basically NLP module takes the user's query and breaks it down into tokens. Next, the tokens are converted into embeddings and is passed to the retrieval or the dialogue manager. This dialogue manager basically takes this input, analyzes analyzes the input. Now because the dialogue manager here have the large language model, so the large language model being able to understand the human context will understand what the user needs actually, and will understand what would be the perfect answer to give. So the LLMs or the dialogue manager, once understanding the question, would go to the knowledge base to fetch the information, or the most relevant answers from the knowledge base, and would rephrase it, and after that it will pass on to the user. So here we are using the Google's Gemini Pro API to facilitate the uh, rephrasing of the knowledge base, knowledge retrieved from the knowledge base. And here internal processing is done for PDFs. For example, we have PDFs, so the NLP module will fetch all the words or text from the PDF and would convert it into the text chunks, and these text chunks would be stored in the vector database, or we called it as the knowledge base. So once the PDFs are converted to knowledge base, it is ready to be deployed, so that the dialog manager would fetch the relevant information as and when the query is asked. The query handling is done by converting every query into embeddings, so that the large language model can understand the queries as well as the knowledge fetched from the knowledge base, and the retrieved answers are ranked based on their relevancies, and the
Excuse me,
most.
sir. Sorry to disturb, but around 7 minutes are over. Can you please wrap up?
Yeah, sure. So after that we have the database which stores the information. So this was the proposed system is having the text documents, dividing it into chunks, and then these chunks are stored into the vector database. This was the part one. Next, the user asks the questions, and these questions is again converted into the text chunks and is given to the large language model. The large language model analyzes the user's query, retrieves the answer from the vector database, and rephrases it, and then gives it back to the user on the user interface. So these were the scores that we took from various benchmarks like MMLU, GSM 8K, and Human Evolve. And Gemini Pro, the large language model that we have used, has the most have performed better than all the other language models. To conclude, this proposed system not only ensures that we have better engagement with the users, and but it can handle uh, complex queries and handle large data. uh, Applications are customer support automation. We can use it in customer support automation, or it can be used in AI research as well. And the future directives are, uh, we can use this AI models in enhancing personalizations, or used can be used in mobile applications as well. Thank you. Do you have any questions?
Rohit,
Yes, ma'am.
so which application you have used for that chatbot? Have you
For
implemented now, right?
Yeah, we have written the code. That chatbot is
Yeah.
uh, uh,
So on which platform you have written that code?
uh, we have written the code using Python language, and the backend is Python. The front end is used using React.js, and the communication between the front end and the backend is using Flask.
So you have used API, right?
Yeah, the API key, right?
API key. So which
Yeah.
kind of API key you have?
So it's
Sorry, Java.
no, it's a
Hello.
large language model API key. So we get a API key from Google Gemini
From
Pro.
where you get? Okay, from Google.
Yeah, so they provide a API key. So if we want to have a communication with the large language model, we have an API key. We can integrate that API key in our pipeline itself, so that all the queries that goes from our code, uh, it would be given to the large language model,
Right.
and the query would be fetched from the large language model itself.
Okay, so you have used already implemented API. Am I right?
Yeah, we have all the implementation part is in the backend vector
Mhm.
storage, where how we are converting the user queries or the PDFs and convert it into the knowledge base. So that is the main implementation.
Okay. 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 Thank you.
Thank you.
Okay.
Thank you for your presentation, sir. Moving on next, I'd like to call Mr. Hitesh Kumar for his paper titled Role of AI-powered chatbots in Mental Health for Anxiety and Depression. Sir, can you please start with your presentation?
Yes, good evening, ma'am. Am I audible?
Yeah, you're audible.
Yeah, just a minute. Is the screen visible as well?
Yes, it's visible.
Uh, okay, ma'am. It's visible?
Yes, yes, start.
Okay, ma'am. Uh, Good evening. I am Hitesh, and I am here on behalf of my co-authors, Atharv, Aishwarya, Aman, and our guide, Darshana Naik, ma'am. So we are going to present on the topic AI-driven chatbot for anxiety and depression. So first of all is like our main motivation behind choosing this topic was like there is a growing concern of anxiety, depression, and mental health among people nowadays, and it is more common among the age group of uh, like the youth or the Gen Z millennials, which we say around 20, 25 plus, 30, 35 plus. And also this concern is like very common in tier 1 cities, the metropolitan cities, and also the tier 2 cities, towns, villages are also like having this kind of issues. So, like in the contemporary society, mental health issues, which are like particularly depression and anxiety, we have touched upon these two domains only. These are very increasingly prevalent, and timely support and resources for these mental health issues can be very challenging, like due to various factors, which includes like social stigma, lack of awareness, or the limited availability of mental health professionals, therapists, or yeah, the medical professionals. So to address this issue, like we propose the development of a mental health chatbot
which is particularly aimed at providing like immediate assistance and resources to the individuals which are experiencing depression and anxiety. Yeah, so this is our problem definition. Mental health issues like depression and anxiety are increasingly common, and yet accessing timely support is hindered by social stigma and resource scarcity. So, we are proposing the development of a mental health chatbot to provide immediate assistance and resources to those in need, and to cater them and to help them uh, overcome this issue. The current methodology that is used is like the current prevalent mental health chatbots like tests by X2AI. They analyze conversation content to respond to users' emotion lead across various platforms. So these chatbots are structured into modules which focus on different treatment modalities, but are not substitute for traditional therapy. Like do not, they are not an alternative for therapy for conversation between a patient and a doctor, patient and a therapist. They are just pre-fitted, and few things are like missing from them. So these chatbots face limitations such as lack of empathetic responses, absence of emergency contacts or hotline. Uh, Ma'am, am I visible? Is the slide changing? Can
Yes, sir, it
someone
is
come?
visible.
Okay. Yeah, so additionally, issues of user privacy and anonymity are not always adequately addressed, which lead to potential concerns about stigma and confidentiality. Uh, Sorry for the interruption. Yes. So the methodology that we are trying to create, it consists of four major objectives, which are empathetic responses, emergency contacts, mindfulness techniques, and resource suggestions. So empathetic responses, they will ensure that the chatbot provides supportive and empathetic interactions. Emergency contacts will automatically provide users with hotline numbers during the condition of crisis or during very grave situations. Mindfulness techniques and resource suggestions would provide suggestions like music, support groups, meditation, exercises, which are like very essential and very helpful in managing anxiety and depression. So, touching these four objectives will provide a more holistic and empathetic and a more user centric mental health support system. The system requirement for a chatbot is very minimal. Like the software requirement consists of Python, TensorFlow, Keras API, analytical libraries, and it is hosted on web server platforms like Heroku and AWS. The hardware requirement are not such specific. Yes, and now coming on to the functional requirements. We have ensured that all the functional requirements are satisfied. The first one, which is natural language understanding. The chatbot is capable enough to address user input and understand the input given by the users regarding depression and anxiety, and process their language or the inputs that they are providing in text forms while analyzing conversation context to offer particular responses, pertinent responses. The second functional requirement that we are fulfilling is empathetic response, which is like the chatbot is offering empathetic and supportive responses. It is utilizing the language that demonstrates empathy, understanding, and validation of users' emotion and experiences. The third one is resource suggestion. That is, the chatbot is offering personalized coping technique suggestions, which include like mindfulness techniques, yoga, music, support groups, and immediate assistance options like hotlines, which are like the emergency support, which is the next functional requirement that the chatbot is able to detect and assist users in the event of any crisis, and providing the users the access to hotlines and emergency services while also encouraging professional help seeking and providing relevant contact information. Yes. We have analyzed a total of four research papers around our project. The first one is the study of AI chatbot for depression. And in brief, the paper focuses on understanding user engagement with AI chatbot, and it utilizes surveys, interviews, user interaction data, and to gather the insights into user behavior and preferences. The second one is conversational AI for mental health support. It also summarizes the effectiveness of chatbot in mental health interventions and highlight the potentials of a conversational AI as a substitute for emotional support. The third research paper that we have assessed is the impact of AI powered chatbots, and it was basically a medical paper, and this analyzed user satisfaction levels and also the methodological gaps to provide recommendations. Similarly, I will now explain the use cases. The first use case is the interaction with the chatbot. The basic flow of events that happen is a user generally initiates a conversation, and the chatbot also acknowledges the user and greets. The user expresses his or her feelings, symptoms, and asks the relevant questions. The chatbot analyzes user input and provides appropriate responses. The second one is accessing resources. So the user expresses interest in accessing resources, and the chatbot will provide a menu of available resources like articles, hotlines, music, exercises, something. And the user will select a resource from the menu, and the chatbot will provide the selected resources. The third one is emergency support, and this one is like basically activated in the moments of crisis or in the moment like where the situation is very grave and the user may require emergency support and immediate assistance. The chatbot will recognize certain patterns, certain keywords, certain words that will prompt it to activate this emergency support use case. Yeah, so here is the simplified diagram. There is a user and the interaction with the chatbot happens. There are two use cases that we have covered: accessing of resources and emergency support. The system design is as follows: there is a data repository which holds the training data, and there is a model which processes the data, which acts upon this data and creates a and creates a model which help and the model is getting trained with the help of this data using successive epochs like successive times which the whole data passes through the model, and then a chatbot instance is created where there is a chat interface which can be like the command line interface or GUI, graphical user interface, and then there is the end user which will utilize the interface provided by the chatbot. Yeah, so this is the flow of interaction. The user interacts with the system through the user interface, which is done by providing an input. The input is then passed to the natural language unit, which uses the user intent classification to identify the intent of the user, and context information adds contextual understanding. The third one is the decision making. The decision making engine, which takes the classified intent and context information to decide upon the next step. The fourth one is action and retrieval. If necessary, then the decision engine may instruct the action execution to perform an action and gather all the responses required information from the data repo, which is the data file that we have input. The second last is the response generation. Based on the decision and the retrieved information, the response generator creates a response and then it is sent back to the user. Yes, so this is the basic system architecture. There is a user interface, there is an NLU unit, which then consists of a user intent classification and context information. After this, the decision is taken.
Excuse me,
The
sir.
decision engine.
More than 8 minutes are over. Can you please wrap up?
Yes, ma'am. Yes, ma'am. I'm wrapping up. The decision engine takes the decision and fetches the information from the data repository and sends it back to to the response generator, which caters to the needs of the user. Yes, so the algorithm that we have used is a pre-processing and classification based algorithm that takes help of a user intent database, which consists of the dataset consists of data which is classified into tag, pattern, and responses. So here are the few examples of the tag, patterns, responses dataset that we have used. The tag is the generalized tag. Patterns are what are the like uh, possible language or possible sequence the user may input, and the responses is the various kinds of responses that can be generated. Yes, so the model is trained for 600 epochs, and across that, the accuracy is gradually improved and the loss is gradually decreased. So we are achieving an accuracy of about 91 to 92% in this. Uh, yes, so here is a slight example of the conversation between the chatbot. Suppose, where can I find support groups? Then the chatbot replies that support groups can be very helpful. It gives some sample websites and some songs that we are suggesting that was very helpful. I have no friends. If the user inputs, then the chatbot may support the user by providing suitable empathetic responses. So, yeah, in the conclusion, we would like to say that this development of this mental health chatbot, it represents a significant and a more challenging step towards addressing the pressing need for accessible and immediate support for individuals facing this issue of anxiety, depression, and other mental health issues. So, by like taking help of these techniques and touching upon all the objectives like empathetic response, natural language processing, and resource suggestion, we try to provide a personalized touch to the needs of the user. And yes, um, that was it. Thank you.
Hitesh, can you please explain me safety features?
Ma'am, can you repeat?
Safety features. Can you
Safety
please
features.
explain me
Right,
safety
ma'am.
features? Yes,
Uh,
right, safety features.
Suppose like there is a very demanding situation or emergency kind of situation. Suppose a user is facing suicidal tendencies, let us say. So the chatbot is trained in such a way that it will detect the words, the certain patterns that may lead to suicidal tendencies, and then it will also suggest the user, it will also provide the helpline or hotlines to the users, and as well as it will uh, notify certain support groups or certain help groups for immediate and prompt action. So by this way, we are implementing the safety and emergency features.
Okay, so okay, thank you.
Okay, thank you,
Okay,
ma'am.
thank you.
Thank you for your presentation, sir. Moving on next, I'd like to call Lakshmi Patil for the paper titled Transforming Sign Language into Emotion Enhanced Speech with Machine Learning. Can you please start with your presentation?
Yes, ma'am, I do. Just a minute. Ma'am, is it visible?
Yes.
Okay. Good afternoon, ma'am. I am Lakshmi Patil. I am honored to present our research on transforming sign language into emotion-enhanced speech and machine learning. This project aims to bridge the communication gap for deaf and hard of hearing communities by not only translating sign language into spoken words, but also embedding the emotions into synthesized speech. So here's the agenda. Moving towards my next slide, our objective is to develop a system that translates sign language into spoken language while effectively capturing and conveying emotions. So basically our problem statement is that communication is a fundamental part of human interaction. However, for a deaf and hard of hearing individual, communication barriers often create challenges in both personal and professional settings. While existing sign language translation systems, it converts gestures into text or speech, they often fail to capture the signer's emotional tone, leading to robotic or impersonal interactions. So our project aim is to bridge the gap by developing a real-time sign language recognition system that not only translates gestures into speech, but also integrates emotion detection to enhance expressiveness and accuracy. So uh, this is the literature survey. So we have taken into consideration the existing methods which are used here. ResNet 50, they have achieved 98.2% accuracy in gesture recognition. Then Saudi Deaf Assistance System, a multi-model system with 97.25% accuracy. Then ASL gesture recognition using OpenCV, they have achieved 85.2% accuracy. CNN-based gesture recognition with DC-Gen augmentation, they've reached 90% accuracy. Also, there are certain limitations over the existing methods, like inability to capture emotions, lack of real-time performances, and limited dataset diversity. So over here, we have used some key technologies like CNN and YOLO V9 for accurate and real-time gesture recognition, VGG system and ResNet for facial expression-based emotion detection, LSTM for capturing audio-based emotion cause, then Tectron 2 and WaveGlow for natural and expressive speech synthesis. So our system workflow will go like first of all sign language recognition, which we are going to develop with the help of CNM and YOLO V9 algorithm, identifying the hand gestures to interpret our sign language. Then we will detect our emotions using the algorithm VGG16 and ResNet to analyze the facial expressions, while LSTM will extract the emotional features from our audio cause. Then the voice synthesis with emotion embedding using Tectron 2 generates speech with emotion modulation. Then real-time processing and user interface to give user a user-friendly system which will ensure seamless interaction, feedback, and real-time responses. Then, ma'am, we have data collection and pre-processing. So over here, we use well-established data sets and ASL finger spelling, RWTH Phoenix weather to 2014, and for emotion detection, we have used these data sets. There are also data augmentation techniques like rotation scaling, flipping, and background alterations, which will enhance the dataset diversity. Then these are the pre-processing steps we used over here, like normalization, standardizing data for better model convergence, feature extraction we have used over here. This is the system architecture of our project. First of all, as we can see, people who cannot speak or hear use hand gestures to communicate. The system captures these gestures as an input, and then processing and segmentation perform. Here, the capture gestures are processed to remove noise, and the system then segments different hand movements for better recognition. And then feature extraction and gesture detection will happen, where important details like hand shape, movement, and finger position are analyzed. Then the system matches these features with a pre-trained data set to detect and the correct sign. Then it is converted into text and voice. So once the sign is recognized, it is converted into text. The text is then converted into speech, making it easy for others to understand. The translated message is displayed on a computer screen and spoken aloud using voice synthesis. And Our system bridges the communication gap between sign language users and non-signers. It makes communication faster, more accessible, and inclusive for everyone. So the model development basically goes through three models. There are basically three models over here. The first one is the sign language recognition, second one is the emotion detection, and third one is voice synthesis. So at first we will recognize the signs from the mute and hard of hearing peoples using CNN based classification, YOLO V9 and LSTM. Then for detecting their emotions, we are using VGC16 also LSTM and multimodal fusions to combine facial and audio features for enhanced emotion recognition accuracy. Then there will be voice synthesis, where Tectron 2 for natural speech generation will be used. Then WaveGlow we are going to use for high quality audio waveframes. So our system integration will look our system will seamlessly integrate the multiple components to enable real-time emotion enhanced sign language translation, and we'll use a real-time processing pipeline where we will capture sign language gestures and facial expressions. We use CNN and Uyolo V9 to identify hand gestures. So after that, there will be user interface features, just like a gesture recognition feedback provides real-time visual confirmation of detected signs. Also, there will be emotion indicator, which will display the recognized emotion alongside the translated speech. And there will be a control over the voice output, that if the mute or hard of hearing people, they will give input in the form of sign language, and we will convert it into form of text and speech with emotion enhancement within it. So the experimental result of the previous models, as I mentioned earlier, they will give the following accuracy. Like in gesture recognition, we will achieve 95.6% accuracy. In emotion detection using VGG16 and ResNet, we will achieve 92.4% accuracy. Then speech synthesis with emotion will achieve high realism and expressiveness. Then with after comparing with the existing models, our model demonstrates a significant improvement in both accuracy and real-time performances. So for concluding, I have to say that we have successfully developing a system that translates sign language into speech while incorporating the detection for more natural communication. And this innovation significantly enhanced communication for deaf and for mute and hard of hearing individuals. So uh, this innovation fosters more innovative and expressive interactions. And in the future work, we expanded the dataset to include more sign languages and reduce real-time latency. We also added multilingual support and integrated the system into various communication platforms. uh, so we have also used various references. And thank you for your attention. I'm happy to answer any questions you may have. Yes, ma'am.
Thank you. No questions from my side.
Okay, ma'am. Thank you.
Thank you for your presentation, ma'am.
Thank you.
I sincerely thank all our authors for their excellent presentations and contribution in this session and all the previous sessions. I hope this session was informative enough. We'll be happy to have you in the 10th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of SMARTCOM 2025. I'd like to thank our session chair, Dr. Nidhi Tiwari ma'am. This is a token of appreciation from the team of SmartCom 2025 and Global Scholastic Research LLP. Thank you, ma'am, for your valuable presence.
Ma'am,
Yeah.
ma'am, my paper has not been presented, ma'am. I am directed to the Zoom meeting, but my name has not been called for the paper presentation.
So, wait a second. So we had previously called out your name, but you were not there in the meeting. No problem, but we'll take it right now.
Okay, ma'am. My screen is shared.
Yes, sir.
Good afternoon, everyone. My name is Dev Sharma, and I'm from Dayanand Sagar University. We had developed an efficient smart agriculture monitor system using an information of things, IoT. So these are our authors.
So this is an overview of our paper that Introduction to a Smart Agriculture, IoT but Smart Farm and IoT Smart Agriculture Architecture, Crop Production Forecasting and Implementation of IoT with Raspberry Pi, Software Service Application and Livestock Manager and IoT app features. So will the problem statement what we get is the manual farming practices which is made by our farmers basically leads to a water waste, low productivity and labor intensive, lack of real-time data on soil moisture, weather and livestock health. So we had developed an IoT-driven smart agriculture using sensors, soil moisture sensors, temperature sensors and humidity sensors. And the processor which we use is Raspberry Pi with the cloud integration facilities. And the key benefits which we are getting resources efficiency and automated irrigation, livestock tracking, and data-driven decisions. So utilizing it properly will be one of the major concerns. Proposing the idea is to build an irrigation structure which helps us to proper and time-to-time irrigation of water as it needed. The collaboration of the system leading advancement of technologies in cloud computing, algorithm optimizations, and IoT. This self-contained irrigation system uses an affordable sensors to detect and challenges soil quality, soil moisture, and weather. The gathered data will be sent to the cloud, and the traditional process of devices signals will be used. Now, if we go to advanced and try to be the more efficient, then we have a different technology for stable connectivity. We are using here GSIM. Basically, it is internet port connections will be there. We can instant SIM. Either it will be a 3G to 5G support we are given. It depends upon the network connectivity issues, and also if suppose 5G is not supported, device connectivity is already lower to the 3G or 4G, whatever it will be the requirement. Basically, we are using actuator as a water pump and sprinklers. Sensors we are using temperature sensor, water level sensor, and livestock tracking sensor. Connectivity we had talked about Wi-Fi, GSM, and cloud integration. Now we will move on to the crop production forecasting. So basically, technologies which use FUSI means FCM for soil classification and multi-layer perception for yield prediction. Data sources we are connecting with the sensors plus meteorological report. Weather reports will be added in the device or in the cloud integration we had done it so that irrigation decision will be made. What the device will do and what the software will do, I will elaborate you here. Suppose in the software, the weather data reports of 5 years will be set and the data pre-processing will be there. Suppose if missing data are there, so this will be reoccupied and the data will be recreated using the AI tools. And then the weather forecasting will be done using RNN model. Basically, we have to consider soil parameters, especially the soil pH, fertility, and the type of the soil and drainage capacity. Now, the confluxing the weather data with the soil parameters, crop selection will be done basis on that. Suppose n number of crops will be submitted to the site. From there, the AI tool will pick up the crop which will be beneficial for that particular time. Now we'll move to implementation. So implementation part, the Pi board will be connected with the power supply. Power supply here, the two things are major things which we encountered during the making of model. That power supply, the board is rechargeable board. We can charge the board, but this board will be used for continuous monitoring. So we are giving the power supply from the direct switch boards, or a generator source will be there for giving the power supply. And then the data, whatever data we store in the Raspberry Pi will be simulated towards the cloud data. And then the relay is there. From there, the water motor is connected. And especially the soil moisture sensor and DHT11 sensors are there. Now for SaaS application, software as service application, we are including the Granular and AgriV 360. Basically, these advanced farm management platforms help farmers to track expenses, schedule tasks, and optimize the resource allocation. They provide insights into labor management, farm financials, and predictive analysis for the yield optimization. And the functions we got is soil pH and nutrient analysis, crop planning and forecasting, historical price trends and market analysis, quality assurance and supply chain management, and IoT integration for precision farming. Key features what we are getting GPS collar and health sensor. Basically for the cow and the cattle, especially for the cattle feed, we are making the GPS collar and health sensor. Basically for lamb and the cow. So each livestock is fitted with a GPS enabled collar with a track that location prevent loss or theft. These collars also include sensors to monitor vital health parameters such as the body temperature and heart rate, providing a real-time updates to the farmer. And the boundary alerts and automated gazing. Farmers can set virtual boundaries for the livestock if animal crosses this boundary and alert is sent via the mobile application. Rotational grazing schedule can be managed to optimize the pasture use, ensuring livestock move to fresh grazing areas at the right time. Automated feeding and watering systems. Smart feeders release their appropriate amount of feed based on their animal dietary needs, reducing the wastage and ensuring optimal nutrition. Similarly, automated water dispensers track water levels and refill as required, ensuring livestock have a constant supply of clean water. Air quality monitor using cattle sheds. IoT-enabled air quality sensors measure the level of ammonia, carbon dioxide, and humidity with the cattle sheds. If harmful gases exceeds the safe level, ventilation system are automatically activated to improve the air circulation and maintain a healthy environment. So IoT cow health monitoring system. So here I have the flow chart. How does the model will work? Activity monitor, body temperature monitoring, and the heart rate monitoring, irritants monitoring, rumination, and humidity will be measured through that device. Sensors, what we use is accelerometer sensor, temperature sensors, heart rate sensor, pedometer sensor, rumination sensor, and humidity sensor. And it will be connected to a Wi-Fi, a Bluetooth, and a Zigbee and RFID. If RFID is not available at that particular time, till Wi-Fi and Bluetooth, we can do the simulation. After that, IoT features. Dashboard is customizable. UI with the soil moisture, weather alerts, livestock locations, graph temperature set and farmer for different local languages. We are training the AI model like that so that they can support the local languages. If we talk about its conclusion, so before conclusion, I want to show you the device setup and all everything. So basically, I will first name the sensor what we use. The water level sensor, we are using the ultrasonic sensors, which are SCS04 LB Max. And for soil moisture, we are using the gypsum block, which is natural sensors. Connecting it with the board directly, it will be used for a long term. And for temperature sensor, we are using the thermistor sensor. For power supply board, either it can be charged or connected given to the switch boards. And secondly, we are connecting it with a VCC 5 volt and the GND grounding it with the trigger GPIO 23 board. Eco CPIO 3.3 volt. Basically, the power supply will be a 3.3 volt to a 5 volt, so it can consume the less power. It will be cost effective, so it will not like a burden towards the farmer. And we trying to keep the device price to be a cheaper. And conclusions are benefits, increase productivity, reduce resources, waste, sustainable practices, real-time monitoring for crops and livestock. Future scopes are scalability for a large firm, blockchain integration for secure logs, enhanced AI for disease and prediction and climate resilience. Reference used for paper only. Tampada, C. Nandini. So, and now I have the device. I will show you the device. So we are making the device with a collaboration of Gills Instruments and Co. We are designing the device. This is with us. We have to proceed with the testing. So few loopholes are there in device. We are still trying to recover that loopholes, and we will go for testing. So this is our presentation. Anyone has a question can ask.
Any questions from the session chair? I guess no questions.
Okay.
So finally, we've concluded this session. I'd like to thank our session chair for chairing this session. Give me a second. This is a token of appreciation to the session chair. On behalf of the team SMARTCOM 2025 and the Global Knowledge Research Foundation and partners, thank you, ma'am, for your valuable presence. And now I kindly request everyone to please switch on your cameras for a quick snapshot. I kindly request everyone to switch on their cameras for a snapshot. Thank you, everyone. Have a good day.